Before we get started on the note sheet today, are there any questions over the homework assignments? Any questions over any of the homework problems? Any that y'all want to look at?
Could you, I know this is old, but do we do 10 yet? Can we do 10?
Okay.
4.2.
4.210. X to the fourth. Minus 9x cubed minus 4x squared plus 5x plus 6 minus 2x to the fourth plus 3x cubed minus x squared plus x minus 4. And whenever we subtract two polynomial expressions, the first one's signs are going to stay the same. But the second one, we do have to distribute the negative, which is going to make it negative 2x to the fourth minus 3x cubed plus x squared minus x plus 4. So all the signs of the second one change from positive to negative or negative to positive. Now at this point here, we can combine like terms. Well, our 7x to the fourth minus 2x to the fourth is 5x to the fourth. Negative 9x cubed minus 3x cubed would be negative 12x cubed. Negative 4x squared plus x squared would be negative 3x squared. 5x minus x is plus 4x. And 6 plus 4 is plus 10. Yeah, we can combine them once we get the signs correct. Any other questions over the homework assignments?
What about like a cube?
Okay.
Find a product. Oh, you put that in your calculator.
We multiply it out.
Okay, that
So
should be easy. You just dum. Okay.
Yep.
What about like 27? You also multiply?
So you'll multiply those two first.
And then you put the terms.
Like terms together, then multiply it with the third one. Now, we're skipping 4 for the time being. If we do have time to get back to it, we will. But if not, we're just going to move on. Now, the biggest thing that comes out of 4 is, well, we're covering factoring, but we do have the factoring theorem. And the factoring theorem states if x minus a, if we solve this for a and divide it by the given polynomial, and that value of a, when divided, gives us a remainder of 0, it means it's a factor of the polynomial function. And it also works out that if it is a factor, it means whatever value a is also going to be a solution. And that's really the biggest thing that came out of 4. But if we do have time, we'll come back to it. Because what I want to start doing today is 4-5. We're going to start 4-5 today. And 4-5 is revolving around solving polynomial functions. Now, the only polynomial functions that we've had methods for solving for is quadratics, our second degree polynomial functions. And there's 4 ways that we had to solve these here. The first one was factoring. We set it up as multiple sets of parentheses, or multiple things being multiplied together to equal 0. One of them must be 0. And this does work for higher degree polynomial functions. And we're going to do a few with factoring today. The next one is graphing. We can graph the polynomial function, and whatever values of x make the y value be y value equals 0, solve this here. Because we look for whatever values of x make y be 0. And the last two that we had was the quadratic formula completing the square. But again, these mainly worked for quadratics, where the degree is 2. Where the degree of the polynomial function is 2. Quadratic functions don't normally work with the quadratic formula in completing a square, don't really work too well with anything bigger than a quadratic. It somewhat works with quartics, degree 4s, but it's still a little clunky. It's not very well suited to it. But these here. Now, at this point, we don't have any way to solve for anything bigger than a quadratic, but if we can decrease the degree from whatever the degree we start with down to a quadratic, a degree 2, we can solve it from there. Because if it is a degree 2, the quadratic formula in completing the square will always work. So we'll end up using factoring, graphing for sure to try to decrease the degree from whatever we start with down to a quadratic, and then we can solve it from there. So if we look at the first one we're solving, 2x cubed minus 12x squared plus 18x is equal to 0. We have this one here. And we want to solve this by factoring. Well, we don't have a way to factor this as it is, but we can start off by looking for a greatest common factor. Is there something in common with 2x cubed, 12x squared, and 18x? 2. We can indeed factor 2 out of all three terms. Is there anything else in common with these three terms? They all have an x. We have x cubed, x squared, and x. And the number of x's we can take out is equal to the degree of the smallest one. Since the smallest one is x to the first, we can only take one x out. Because if we take 2x out of 2x cubed, 2 divided by 2 is 1. And if we take 1x away from x to the third, we're left with x squared. Minus, if we factor a 2 out of negative 12 divided by 2 is negative 6. And if we take 1x away from x squared, we're left with x. And if we factor 2 out of our 18, 18x divided by 2x, 18 divided by 2 is 9. And if we take 1x away from the single x, we just have 9. Questions on this here? So if there is a greatest common factor, we can factor it out. So it gives us 2x times x squared minus 6x plus 9. Well, factoring that out does give us a quadratic, x squared minus 6x plus 9. And we can factor it. 2 sets of parentheses equals 0. Now, interestingly enough, there is a way to check to see if something is factorable, if a quadratic is factorable. And that's our square root of b squared minus 4ac. This here is a way to check for factorability. If we plug this in, the values of a, b, and c into this and get a whole number, we get a number, a positive non-decimal number, then it tells us that the original is factorable. So this is just to, we're doing this or using this to just check to see if we can factor. And in our case here, a is 1, b is negative 6, and c is 9. So when you say second square root, negative 6 squared minus 4 times 1 times 9, and we get 0. Because this is a whole number, a number that is not a decimal, or an imaginary number. All it's telling us is that this here is factorable. We can factor it. And when we factor it, we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term, which is negative. So we would have negative and negative. Factors of x squared are x and x. Our factors of 9 are 1 and 9, or 3 and 3. Which factors do we want to try first? 3 and 3. And we can check this here to see if it works. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x is negative 6x, which is the middle term we wanted. So factoring out the 2x gave us the x squared minus 6x plus 9. And we were able to factor it to x minus 3 times x minus 3. So our original cubic equation factors down to 2x times x minus 3 times x minus 3 is equal to 0. Questions on how we got to this here? Well, now we have three things multiplied together to equal 0, so one of them must be 0. So either 2x is equal to 0, x minus 3 is 0, or x minus 3 is 0. And at this point, we just need to solve for the value of x. So 2x equals 0. Here we can divide both sides by 2. 2x divided by 2 is just x. 0 divided by 2 is 0. Well, 2 times x, two things multiplied together to equal 0. One of them must be 0, so x has to be 0. Let's look at the x minus 3 here. If we're solving it, we would add 3 to both sides. Our negative 3 plus 3 would cancel. 0 plus 3 is 3. So x is equal to 3. In our last one, we would add 3 to both sides. Minus x is 3. So the solutions for this here are 0, 3, and 3. Yeah. Or have to do it twice?
No, like have to do the x equals x.
I mean, we could write it as x equals 0, comma 3, comma 3. But we do need to list out the 3 solutions. Any other questions? Now we can check our solutions if we want. And to do that, all we've got to do is plug each of those values back into the original equation. So we can say 2 times 0 to the third minus 12 times 0 squared plus 18 times 0 is, surprisingly enough, 0. So we just plug 0 back in. We can do the same thing with 3. 2 times 3 cubed minus 12 times 3 squared plus 18 times 3. And again, we need this to equal 0. So all we did to check it was take the values of x that we got for the solution, 0 and 3, and plug them back into x. And in both cases, we did get a value of 0. So it's saying that they are indeed solutions. Questions on this here? So using factoring, we were able to solve a third-degree polynomial function. And we ended up getting 3 solutions. if we look at this one here, 5x cubed minus 40x squared plus 80x equals 0, is there a greatest common factor between these three terms? And it is. 5 does go into all three. Does anything else? X. So we'd factor a 5x out of all three terms. If we factor 5x out of 5x cubed, x squared. Because our 5 factors out. 5 divided by 5 is 1. And we remove an x from x cubed, we get x squared. Minus 40 divided by 5 is 8x. 40 divided by 5 is 8, and when we take an x away from x squared, we're left with a single x. 80 divided by 5 is, and the x factors out completely. So we have 5x times x squared minus 8x plus 16. Two sets of parentheses, because there's a good chance that x squared minus 8x plus 16 will factor. I can check it in the calculator to see, because we can go second square root, negative 8 squared minus 4 times 1 times positive 16 does give us a whole number 0, not a non-repeating, non-terminating decimal, so it is factorable. To factor it, we look at the third term. If the third term is positive, the signs are the same and match the sign of the middle term, which would be negative and negative. Factors of the first and third term. Factors of x squared are x and x. Because that's the only set of factors, so we can just plug it in. Factors of 16. 1 and 16. 2 and 8. 4 and 4. Which set of factors do we want to try? 4 and 4. And if we check this here to see if this is the correct middle term, x times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4x minus 4x is negative 8x, which is the middle term we wanted. So those are the correct factors. Any questions on this here before we move on? Since we do have two or more things multiplied together to equal 0, one of them must be 0. Well, 5x equals 0. We can divide both sides by 5, telling us x is, surprisingly enough, 0. X minus 4 equals 0. What can we do first? We can add 4 to both sides. Our negative 4 plus 4 is 0, leaving x by itself. 0 plus 4 is 4, telling us x is 4. And our last one, we need to add 4 to both sides again, telling us x is 4. Questions on this here? So this one here, we want to find the zeros of f of x. So f of x equals negative 2x to the fourth plus 16x squared minus 32. and then sketch the graph. So there are ways to go about doing this. We could do factoring. There is ways to factor this to find the solutions. Or we can go on and graph it. Because again, to be able to solve these, we either need to be able to factor them or find some of the solutions to decrease the degree. Because if we can graph this polynomial function, and find some of the zeros, we can decrease the degree by 1 for each solution that we find. So we go over graphing, and we're trying to solve these by graphing, or with graphing. The first thing we're going to do is graph the polynomial function. So for us here, we have negative 2x to the fourth, y equals. So to pull this up, the first thing we need to type in is y equals. So we hit y equals, and then 2x, negative 2x to the fourth. Plus 16x squared minus 32. Is everybody able to type the function in? And once you get it typed in, hit graph.
Oh, my bad.
You're good. Got it typed in. So negative 2. X is next to alpha, the green button. And then the button above division will give us exponents. 4. And then we need to arrow over. Yep. And then we have plus 16x squared. Arrow over. Enter. And we hit graph. So we have these here. Now, there are two places where it intersects the x-axis. And as we went over in chapter 3, even degrees are kind of we talked about. If it intersects the x-axis but does not cross, there's a good chance it has an even multiplicity. There's an even number of zeros at that location. As we look at this here, we do see two values. Because when we graph, we're trying to find out what values of x will make the y value be 0. So one of the x values is 2, and the other is negative 2. So it does tell us x is equal to 2 and x is equal to negative 2. Those are two of our solutions. And when we graph, we're trying to find enough solutions for this here. As we worked through with quadratics, we always found two solutions. And as we saw with our cubics, the last two we got 3 solutions. So there's a good chance that these quartics are probably going to have 4. Now to find the other two possible solutions, well, we need to decrease the degree by 2. And the way that we can decrease the degree by 2 is by doing synthetic division. Because each time we do synthetic division with a single solution, it will decrease the degree by 1. So we set up our synthetic division, and are going to try this here. Now the first thing we can do our multiplication. 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. Our 2 times negative 4 is negative 8. 16 plus negative 8 is 8. 2 times 8 is 16. 0 plus 16 is 16. And lastly, 2 times 16 is 32. And our negative 32 plus 32 is 0. So that does tell us it is indeed a solution, just like we thought with graphing, because it told us that the x value at 2 gave us a y value of 0, so it is a solution. Now it's decreased the degree, because the degree was 4. We did a division, and now the degree will be 3. It's a cubic. But for us to be able to solve, we need it as a quadratic. So we're going to do synthetic division again. Now we don't have to rewrite the problem out with 2, negative 4, 8, 16. We can go on and apply it to this here. And this time we can use our other solution of negative 2 to do this again. Now our negative 2 times negative 2 is positive 4. Negative 4 plus positive 4 is 0. Negative 2 times 0 is 0. 8 plus 0 is 8. And negative 2 times 8 is negative 16. And 16 plus negative 16 is 0. So we get this here. Now if we put the variables back, our last 0, the 0 in the box is the remainder, and we needed the remainder to be 0. Because when the remainder is 0, it tells us that negative 2 is a solution. Our 8 is the term without x, 0 is the term with x, and negative 2 is the term with x squared. So after applying 2 and negative 2, we took it from a degree 4 to a degree 3, from 3 to 2. So now we have a quadratic. And we know how to solve quadratics. That's what the entire last chapter that we went over was. And the reason that all of this is helpful, or we did all this, is graphing it told us 2 of the solutions, so that we were able to take it from negative 2x to the 4th plus 16x squared minus 32 down to negative 2x squared plus 8x. It took it from something that we really didn't have too many ways to factor or solve down to something we could. Now at this point here, we can solve this. Negative 2x squared plus 8 equals 0. And we've solved several of these before. Whenever we don't have a middle term with a quadratic, we can use the square root method, which is just getting the x squared by itself and taking the square root of both sides. So the first thing we can do is subtract 8 from both sides, telling us negative 2x squared is equal to negative 8. At this point here, we can divide both sides by negative 2, telling us x squared is equal to 4. And lastly, we can take the square root of both sides, telling us x is equal to 2. But whenever we take the square root of both sides, we need to add the plus or minus. So it's telling us x is also 2 or negative 2. Questions on this here? Questions on anything we've done so far? So for us, that means that x is equal to 2. Well, I can scroll back up to the top. Because we do have these solutions, but we also have that x is 2 and x is negative 2. So we do have two repeated solutions, a positive 2, negative 2, and negative 2. Questions on this here? We ready for the next one? X to the fourth minus 18x squared plus 81. So again, we can do the same way. We can solve this by graphing. And if we solve it by graphing, figure that out this time, we can start off by hitting y equals. Now we'll clear out the previous problem and type our new one in. So we'd say x to the fourth minus 18x squared plus 81. So once we get it typed in, we're going to hit graph. Now, just like with the last one, this one here is also going to have 4 solutions, 4 values of x that will work for this equation here. Now, to find them a little bit better, we can do second graph. And again, we're looking for what values of x will make the y value be 0. So x is equal to negative 3. And we also have that x is equal to 3. Now, as we saw with the last one, there's a good chance that negative 3 and 3 might repeat because it touched the x-axis but did not cross it. And again, we can look at this with synthetic division to check these two and see if others work, because if we get a remainder of 0, then it is a solution. So we can, do we want to use negative 3 or 3 first? 3. Our numbers going across the top would be 1 for x to the fourth, 0 for x cubed, negative 18 for x squared, 0 for x, and then 81. So the first thing we would do is bring the 1 down. Then we can multiply. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is negative 18 plus 9 is negative 9. Huh? Nope. We are not, unfortunately. 3 times negative 9 is negative 27. 0 plus negative 27 is negative 27. And lastly, 3 times negative 27, negative 81. And 81 plus negative 81 is 0. And we expected it to be 0 because on the graph it gave us a y value of 0, so the remainder should be 0. What number do we want to try next? Negative 3. You can bring the 1 down and do this again. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is negative 9 plus 0 is negative 9. Negative 3 times negative 9 is 27. And negative 27 plus 27 is 0. Now, finding 2 solutions did take the degree of this from a degree 4 to a degree 3, from a degree 3 to a degree 2. And since it's a quadratic, we could solve from here. But as we saw with the last one, there's a good chance 3 or negative 3 could also be a solution, yes? Because it touched the x-axis but didn't cross it. So we could try plugging in 3. or doing another synthetic division of 3. If we do get a remainder of 0, then it's also a solution. If we get something different than 0, then we know it's not. Well, our 3 times 1 is 3. 0 plus 3 is 3 times 3 is negative 9 plus 9 is. So it is a solution. We can do it one more time. What would we try? We're just trying to get it all the way down to simplify as far as possible. Because at this point, we took it from a degree 4 down to a degree 3. Because it was our starting function. Now we have here, you don't have to write this out, x cubed plus 3x squared minus 9x minus 27. We reduced it again and got x squared minus 9. And now at this last step, we did it, and we have x plus 3. Because we took one of the solutions out. Each time we do this synthetic division, we're removing one of our solutions out, one of our factors out of the problem. So we started out with, as we've seen at least for the last one, we had 4 solutions. We took one out, so we should have 3. We took one out, so we should have 2 left. I took another one out, so I should have 3x equals 0. To solve this here, we would subtract 3, telling us x is equal to negative 3. So we found 4 values of x, negative 3, 3, and 3. And there is a set formula for this, and it's kind of dealt in 4-6. But the degree, because these here do have 4 solutions, and there is a connection to that. But any questions on this here? Questions on anything we've gone over so far? So we can factor this, or graph this here, 4x to the 4th, 4x to the 4th. Minus 40x squared plus 36. Plus 36. Graph. How many times does it cross the x-axis? 4. And those values are? Yes? 1 and 3. So by graphing it, we're saying x is negative 3, x is negative 1, x is 3, and x is 1. And as we saw in the previous ones, the previous 2, our degree 4 gave us 4 solutions. This one's a degree 4. We found 4 solutions, so those should be all 4. And really that's it, because if we want to check and make sure, we can do synthetic division and take each one out, and then whichever one's left should be our last one. So across the top, we'd have 4, 0, negative 40, 0, 36. Which one do we want to try first? Negative 3. So we'd go through the process. Negative 3 times 4 is negative 12. 0 plus negative 12 is negative 12. Negative 3 times negative 12 is 36. Negative 40 plus 36 is negative 4. Negative 3 times negative 4 is positive 12. 0 plus 12 is 12. Negative 3 times 12 is negative 36, which gives us 0. Which one do we want to try next? 1. 1 times 4 is 4. Negative 12 plus 4 is negative 8. 1 times negative 8, negative 8. Negative 4 plus negative 8 is negative 12. 1 times negative 12 is negative 12, which gives us 0. So we took q out, now we're down to a quadratic, our x squared. But we do have another solution, yes? Which one do we want to do next? 3. 3 times 4 is 12. Negative 8 plus 12 is 3 times 4 is, gives us 0. At this point here, we can put the variables back in because we're down to a linear expression, 4x plus 4 equals 0. Minus 4 telling us 4x, negative 4. Divide both sides by 4, and it tells us x is, which was our last one we didn't try. So, okay. So we know those are all the solutions that we have because we're able to reduce it by each one, and we got the last one. We will continue this tomorrow.